Okay, classwork 5.4, we are solving equations. While I go through solving equations, I want you to realize there are different ways you can approach this. You want to do what makes the most logical sense to you. You're going to find what makes the most sense, what's easiest for you to figure out. Now, here's a first problem. Know that while we're solving rational equations, a big focus is we've got denominators, and who wants denominators? No one. No one wants denominators. So what we're going to ultimately be doing is multiplying both sides of the equation by denominators as a whole. Now, for number one, it has a particular issue that maybe you see it, maybe you don't. But if I decide to add the fraction over to the right side, so I'm adding it to 0, it looks a lot nicer. Maybe you don't notice that that convenience is there. So I want to talk about also, if you didn't notice it, what would you do? What? Yeah. There are a lot of algebra options of how you end up going about this. If you do get those two separated over the equal sign, then you're going to multiply by the denominator in a parentheses. X minus 1 times 1. And over here, do you see that these two cancel and leave me with just 1? So your big goal is get rid of that denominator. Kill the denominator. And then you have something that you're more familiar with. You can then add 1 to both sides and get what is most likely the answer. Now, the directions say be sure to check for extraneous solutions. Why does it say that? There's only one type of extraneous solution you're going to possibly run into, and that's the issue of denominators aren't allowed to be 0. So if my answer had been x equals 1, I would have had to say that there's no solution because my x cannot make a denominator 0. That's the only thing you have to worry about. You can always check by plugging it into x and see if it makes the equation true, and that double checks that you did all your algebra correctly. But if you feel confident with your algebra, know that the only thing you really have to be careful of is, does it make a denominator 0? And if it doesn't, and you know your algebra is good, no problem. Now, let's say you hadn't noticed that step. I just want to talk about how else you could have gone about this. So you're just looking at this, going, what do I do? You've got a denominator. You need to multiply both sides by that denominator. If you do it right here as is, you're going to have to observe this subtraction because you need to distribute the multiplication of this parentheses over that subtraction. And I'm going to show this slowly. So you have x minus 1 times 1 minus x minus 1 times 1 over x minus 1. On the other side, if you have 0 times x minus 1, hopefully you save yourself the pain and just go, well, that's 0. Then as you look across at what you have, you'll see multiplied by 1, no big deal. Then over here, you want to notice that this x minus 1, the whole purpose of multiplying both sides by x minus 1 was to kill that denominator. And then when you look at what's left over, the subtraction sign, and then this just becomes 1. And so there are multiple ways you can approach the problem, and you'll end up with the correct answer or an extraneous solution that has to be dealt with. But that gives you a couple of options of how that problem could be done. Now, we're going to look at problem number 2 with the blinky screen. Okay, are you ready? Are you excited? Come on, we're doing some fun algebra. Woohoo! And you guys get to be serenaded by our band, if you didn't already hear. Are any of you in band? Oh, okay. All right. Now, where's your denominator? You know what I'm going to do? I'm going to do something for all of our sakes. This is just kind of annoying me. I just want to look at it like this. And then I'm going to erase this over here. I erased it with it. I just want to get this out of the way. We can see it a little bit better without the number sitting there. Okay, do you see that you have a denominator? With a parentheses, multiply both sides by that denominator. Now, with that parentheses, when you look at the left side, as you do this multiplication, you must distribute the multiplication here. So 2 times x squared plus 2 times 2. Now on the other side, the reason you're multiplying is to kill the denominator. What's left? Everybody, show me your hands. What's left? Yay! The number 5. Now it's an equation that you have dealt with before. Since you have just a single x, you've got an x squared, but you don't have any other x's lying around. The easiest way to deal with this is isolate that one single x. So subtract 4 from both sides, divide by 2. And then, do you remember that when you undo a square, you do plus or minus square root? And know that I'm okay if you decide you're going to leave your answer as that. I'm perfectly fine with that. For some of you, you might see other ways this can be written. You can distribute the square root over the division. The square root of 1 is 1. And then there's still yet even another way to write that, but I'm just going to call it a day. I just want to point out to you that the big square root on the 1/2 is also 1 over the square root of 2. But again, it's good enough if you just get it to there. So those were a couple of nicer problems. Then the problems get harder from there. So, you ready? We're in the journey together, right? Ha, ha, ha. Yay. Okay, these extra numbers just kill me. It annoys me. All right, there we go. I have more denominators than I did before. And I want to do as little work. Who wants to do as little work as possible? We all do. So I want you to look at the denominator with the quadratic. Can that be factored? Can you factor x squared minus 5x? How does it factor? Yep. And I want you to notice that you have an x as a factor in two denominators. So you don't want to necessarily just flat out multiply by entire denominators. What you really want to multiply by, what's going to save you the most time, is if you multiply by the least common denominator. I'm going to show you a couple of ways to go about this problem. I'm going to first show you the fastest way if you're able to see it. But if you're not able to see it, I'm going to show you some slower ways to get through it. If you find the least common denominator, you notice that it's x times x minus 5. If that's what you multiply both sides by, this is going to go the fastest it can go. So I am going to big parentheses here. That parentheses is very, very important because of the subtraction. Every time you see addition, subtraction on one side of the equal sign, you're gonna have to deal with a distributive property because we're always going to be multiplying by a denominator. So I'm going to rewrite this because this is a bit much. 1 over x times x minus 5, x plus 7 over x, and then minus 1. Did someone need to say something or just accidentally unmute? Accidental unmuting, I think. So we are going to multiply both sides of the equation by the least common denominator, x times x minus 5. Now, when you look at the left side over here, do you see like, woohoo! Kill the algebra, kill the algebra! Did you guys see that? Did you see it? Did it make you happy? Because it always makes me happy when I get rid of a whole bunch of stuff. It's just pretty. I don't know why, it just is. Now, be careful on the other side. You have to distribute the multiplication over that subtraction. So I have x plus 7 over x multiplied by x times x minus 5. Then the subtraction sign, and now I have a 1 multiplied by the x times x minus 5. Now, what you want to see is this denominator x will cancel with this multiplication by x. And now you don't have a denominator anymore. But remember that a division bar is also a parentheses. So you actually are left with x plus 7 parentheses multiplied by x minus 5 in parentheses. And then the minus sign. And I'm going to go ahead and do distributive property of x. So x times x minus x times 5. Ooh, parentheses is very needed because of that subtraction sign. That's one area that people tend to get bitten really, really badly. Ooh, have I said yet where negative signs belong? Negative signs belong in jail for all the grades they steal. It's true. They oh my goodness. Okay. Now, this is something that you have dealt with before at this point, but let's still take it a little bit slow. You need to multiply these together before you can deal with the minus sign. And I'm going to go ahead and throw on a quick box. X times x, x times 7, x times negative 5, and 7 times negative 5. So I'm getting x squared plus 2x minus 35. Then the minus sign. And I can be ready for adding like terms as long as I distribute the subtraction. What you're really doing is distributing a multiplication by a negative 1. That's going to give me negative x squared, or minus x squared, I should say. And then two negatives together make a positive 5x. Oh, does anyone see something beautiful? I see something beautiful. X squared minus x squared. Do you realize how much work that just saved you? Then add those like terms. And you're almost done. Add 35 to get 36. And then divide by 7. And I didn't make any mistakes there, did I? I should double check. Oh, don't do that. Yep. Okay. On the answer key, I have a very slow, or no, actually, no, I did it this way on there. Sometimes on my answer keys, I'll have a slower process just in case people are confused and need a slower process to watch. So that would be the fastest way to get through that problem. There are slower ways to do it that work just as fine. However, thinking about it, this could get tiresome if I do too many different ways for each problem. So let's go to the next one. Sound good? You might be able to save time if you look at what does this factor to. Not necessarily going to save you time, but it might. So how does that factor? One times 8 and negative 6. Two numbers. What are those two numbers? Uh-huh. Yep. And that tells us how to split up the negative 6x. So inside the box, I have x squared minus 2x minus 4x plus 8 to make this. And then I can see that this first column, both terms can be divided by x. And if that's an x, then this needs to be x and this needs to be -2. And then this is going to have to be -4. And it works out. I've got my factoring. You can do your factoring as quickly or as slowly as you need to do it. And what it turned out to be the other denominators we have on the other side, was this like some problem made to be done this way? This is the kind of magical math that does not occur in real life. But at the same time, it's supposed to be a step toward real life, because straight up getting the full brunt of real equations is challenging, to say the least. All right. So what is the least common denominator? Do you see that that's going to be x minus 2 times x minus 4? You guys are...
What does LCD stand for again?
Oh, least common denominator.
Oh.
Uh-huh. And sometimes it'll be LCM for least common multiple. That's another one that'll show up with those letters. But this one's looking at denominators. What is the least that is in common? And so with being the least common, that means that each denominator you look at, each of those denominators is able to, trying to think of the best way to say it. If I divide my least common denominator by any of these, I will get a polynomial. That's the point of getting that least common denominator. Okay. Are you ready? The real work is about to begin. I'm going to erase some of these extras. And, oh, fine, yell at me. Don't you love it when your computer yells at you and then blinks? You didn't push a button. Okay, here's your equal sign. Put a parentheses on each of the two sides. Observe something very important. You have an addition between two different items on the left side. On the right side, do you see that you do not have an addition or subtraction of any two fractions? So when you multiply by your least common denominator, you're going to have to make sure to distribute the multiplication over this addition. But on the right side, there's only one fraction sitting there, and there's no distribution that you need to do. And we found that that least common denominator is x minus 2 times x minus 4. Now, I'm going to do the distribution. Stop doing that, you silly thing. Okay, so I have x minus 2 times x minus 4 times an x over x minus 2, and now that plus sign. And now I'm going to distribute again. X minus 2 times x minus 4 multiplied by the 1 over x minus 4. Now I move on to, I've got my equal sign. On the right side, I have my 1 fraction, and we did look at the fact that that factored to x minus 2 times x plus or minus 4. So I can write it in its factored form. I don't have to, but I'll be able to see better the cancellation that's about to happen. Now, let me emphasize that you have this addition and this equal sign. That cuts this up into 3 sections, and each of these 3 sections, you're going to destroy each denominator. So, first section, that denominator of x minus 2 will cancel with the multiplication of x minus 2. That's going to leave you with the x minus 4 and also this x as well. Those two are now multiplying, no denominator. Now I'm bringing this plus sign down, and now I look to my middle section. What can cancel? That denominator cancels with the x minus 4. What's still there? An x minus 2 times a 1. Don't need to write times 1. Then I've got my equal sign. And now I look at, oh, hey, ninja fruit slicing is what I picture. And a 2 is all that is left over there. So that work of going through and canceling out the denominators is needed to get this into an equation that is now just a polynomial. So if you remember when we were doing polynomials and I warned you, I tried to warn you at least, that you were going to really be using polynomials in that next unit. We did a whole bunch of work right there just to get it to the polynomial point. And now we do what we learned before. I need to distribute the multiplication of this x to get x squared minus 4x plus, and then that's just an x minus 2. And when I have a polynomial and I have more than just a single x sitting around, I've got to make one side equal to 0. At the same time, I'm going to bring together my like terms. So those two are going to come together and become negative 3x. That's okay if you have Wi-Fi issues. And now I have x squared, and I'm going to subtract 2 from both sides so that I have minus 4 equals 0. Now, once you have a quadratic set equal to 0, what is your next move? Do you remember? If you're desperate, you can always throw out quadratic formula.
Isn't that a polynomial?
Uh-huh.
Oh, so what do you just do, like the x and factor it out?
Yep, factoring. So if you have a polynomial set equal to 0, factoring is the direction that you're looking at. Now, this is a lot of steps, isn't it? It's a lot of steps. And you're going to do the best you can as you do these problems. take it slow because minor mistakes become big issues. So, how does this factor?
X minus 4 and X plus 1.
You got it. And then, once you have factored and you've got it equal to 0, do you remember the next step? Set each factor equal to 0, right? And then add 4 to get a solution of x equals 4. Subtract 1 to get a solution of x equals negative 1. These are both solutions as long as they do not make a denominator 0. So let's check what were our denominators in the first place. Do either of those make any of our denominators equal to 0? Uh-huh. What? Yep. X equals 4 is an extraneous solution. And actually, I'm going to look at that question in chat in just 1 second. So the only solution is x equals negative 1. And then you are done. You can double check it. Let me see. Why do we do equation to 0 but not the equation number 1? That's a good question. Some of these earlier problems, stop blinking on everyone. These earlier problems only had single x's. Once you got out of the denominator problem, so where the cancellation happens, the next line after the cancellation happens, those two problems had one x involved out of the whole thing. And if that's your situation, it's actually easiest to isolate the x. We have to go through an entire joyous time of factoring and canceling. I know, which one is this? Is it? Yes.
Sorry. I have a question about number 4.
Uh-huh.
When we got the x equals, or x minus 4 equals 0, and the x plus 1 equals 0,
Uh-huh.
are you not allowed to, is x equals negative 1 the only solution because 4 was once a negative? Like, why is that?
Okay. So when you solved x minus 4 equals 0, you got x was equal to positive 4 by adding 4 to both sides. The problem is 4, if you plug it in to that x, you make a divided by 0. So it's an issue of take your answer and plug it into all the denominator x's and just make sure that it doesn't create a divided by 0.
Okay.
Yeah. Okay. With 10 minutes left, I need to get the quiz started. And you have 2 more classwork problems to work on. So what I'm going to do is I'm going to release the quiz, but I'm going to keep talking through these 2 problems. You can choose to mute me. You in class can't. But the video's still going to go, and I'm going to keep going until I finish those 2 problems and then stop the video so that you can watch it later. So release the quiz. Boom. Boom. assign to that class. Dun, 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 dun. Come on, Wi-Fi. Come on, Wi-Fi. You can do it. I believe you, Wi-Fi. No, I don't. But there, you did it. Copy. I'm going to post or... Okay, and on number 4, if you isolated x on number 4, you couldn't isolate x because you were dealing with 2 x's written in that equation, and so you didn't have one spot where your variable was located to isolate, and so you weren't able to. Okay, so online, you're not allowed to go until it is 10:50. I'm going to keep working. We are now on number 5. Number 5 has a common denominator of x minus 3. So I'm going to multiply both sides of the equation by that x minus 3. What I have to be careful of is I have an addition over here. What you can do is you can highlight addition between terms and equal sign. The right side doesn't have 2 things. It doesn't have 2 fractions being added or subtracted. So basically, I'm distributing my multiplication of x minus 3 over this addition, and then on the other side, just multiplying it to the 1 term. So I have x times x minus 3 plus sign, and then 6 over x minus 3 multiplied by the x minus 3, and then my equal sign. And then I'm just going to write the fraction times x minus 3. And if you see the cancellation, you can do the cancellation as you go into the next step. But now look at every denominator. Denominator cancels, denominator cancels. And let's look at what we have. We have x times x minus 3 plus 6. On the other side, I have a 2x. And now it's a polynomial type of problem. I need to distribute the multiplication of this x so that I have x squared minus 3 times x. And then I've got a plus 6. With a polynomial, and I don't have just a single x, set one side equal to 0. I'm going to do that if I subtract 2x to both sides. When I add my like terms, I have an x squared minus 5x plus 6. And if it's set equal to 0, then I'm ready for factoring. This will factor to x minus 3 times x minus 2. And then set each individual factor equal to 0. And then you get solutions of positive 3 and positive 2. Let's double check. Positive 3 makes the denominator 0. Extraneous. Only solution, x equals 2. And lastly, number 6. With number 6, you really need to think about that least common denominator. You have an x minus 1. You're stuck with it. You have an x, but then you have a 2 times x. Let's not bring in more than we need to. You just want to look at what is a factor in 2x that hasn't been accounted for yet, and that would be just the 2. So I want to multiply both sides by this least common denominator. I need to make sure that I observe this addition. And I'm going to also highlight the equal sign. And I'm going to multiply both sides by this least common denominator. And
just a reminder, if you haven't picked up your free t-shirt, we'll be distributing them outside the Monday Commons class. Thank you.
okay, so distributing, I have this mess times x over x minus 1 plus, and then again, it's a 2 times x minus 1 multiplied by the 3 over x equals, and now I have a 5 over 2x times 2x times x minus 1. It is time for denominator killing. Ah! No! No! Have mercy on me. No, you're a denominator. Ah! Ah! Ha! 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 I like to cancel with a red pen. If I use a green pen, or was it? Yeah. Then I say that it's like a Vulcan. Anyway, 2x times x makes 2x squared. And then I have a 2 times an x minus 1 times a 3. But I need that x minus 1 in parentheses still. On the right side, I have a 5 and an x minus 1. Now I need to distribute the 6 over the parentheses. I need to distribute the 5 over the parentheses. It's now a polynomial. I need to make one side equal to 0. I'm going to subtract 5x, and I'm going to add 5, and then I'm going to factor. Right now I'm going to factor quickly because we are almost out of time. And this is going to go a +1 here and a -1 there. So set each individual factor equal to 0. And then I'm going to add 1, divide by 2, and subtract 1. And I get 2 possible solutions. Let's make sure that that does not make any original denominator 0. And I think we are good. We have 2 answers. So, oh my goodness, hold on. Okay,
I know you're on this phone.
which ones did not show up? These 2 and...
Oh, that's different classes.
Yeah.
So these are
Okay.
all the ones
So
over there.
that's what's here today. Okay. Okay, I had to deal with attendance really quickly all of a sudden. All right, then the full solutions are here online with the answers to the classwork, and I hope that helps. I need to end